Hi everyone, welcome to our lesson 3.4. We're looking now just at how to solve for any acute triangle using sine law or cosine law, or possibly dividing it into some right triangles and using our primary trig ratios. So let's go ahead and get started. We're in our notes 3.4, solving acute triangles. A quick summary of what we've covered up to now. We can use what we know to solve different problems where we have an acute triangle. We can use the sine law. We can use cosine law. Or if we have a right triangle, okay, in our problem, so if we divide our acute triangle into two right triangles, we can use the primary trig ratios, cosine, sine, and tan of an angle. We just have to look at what we're given and decide which relationship we'll use. So a quick summary that we have here is sine law can be used whenever I have two sides and an angle opposite one side. So if I have an acute triangle like this, remember that if I have an angle, I have to, in order to use sine law, I must have an opposite side length. I have to have that side angle relationship, and then any other side, okay, will allow me to use sine law. Also, if I'm given any two angles and one side, I can always use sine law. So again, if I have two angles, any two angles, because if you have two angles, you really have three angles. You could find out your third angle quite quickly, okay, and any side at all. Okay. And remember, if you have two, you really have three because you know that all three angles have to equal 180 degrees. So that third angle is not hard to find. Okay, well, when do I use cosine law? I use cosine law if all I have are sides. So if you have an acute triangle where we're given side, 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 no angles, we can't use sine law. We have to use cosine law. Or if I have a contained angle. So if I have a side angle side relationship, so I have a side, an angle that is sandwiched in between, and then another side on the opposite or right beside that angle, so this is called a contained angle, then I can also use cosine law. Notice that that relationship there, side angle side, does not allow me to use sine law. So we have to just think about it, look at it and say, which relationship can we use? Let's do some. So how will I solve the unknown side length or angle? We're not going to solve it. We just want to think about how we would, what method we would use. So let me give you some values. So for example A, we're going to call this triangle L, K, J. Okay, and let's say that we're given J and it's 73 degrees, and we're given small l, okay, across from angle L, and it's 5.8 centimeters. And let's say that small j, side length j over here is equal to 6.6 centimeters. And I want to find angle L. So this is the angle that I want right here, angle L. Okay, so to find angle L, what would I use? Well, let's look at the relationship that we have here. I have two sides and one angle, but the angle that I have is not a contained angle. This is not a side angle side relationship, okay? Because I have this side over here, I don't have the side length K. I'm not given the little side K between J and L. So this is a side-side angle relationship that I have. So I don't have a contained angle. And the angle that I have, okay, so I have an angle that is opposite a known side. So when I have an angle, okay, angle J is what I have here, and I also have side length J, so I could use the sine of J over little j is equal to the ratio of L, or sine of L over L. Because I have side length L right here, and I'm looking for angle L. So I would use sine law. And I would go ahead and solve for angle L, plugging in the 3 that I know. Okay. So that would be a sine law question. How about the next one? Let's do this here. So let's call this XYZ, this triangle. And let's say that we're given 0.9 centimeters for side length Z. And for side length Y, I have 1.2 centimeters. And for side length X, I have 1.1 centimeter. Okay, something like that. Well, when we see this triangle, we recognize that we have 3 sides. This is a side, side, side. And without any angles, I can't use sine law. So I will use the cosine law for this question. Okay, to solve. And if the question here was, let's say that we were looking for obviously we're looking for an angle. Let's say we're looking for angle Y here. Okay, then I would go ahead and set up my cosine law, and it would be y squared, side length y squared equals x squared plus z squared minus 2xz times the cos of angle y. And I would have to rearrange that for angle y, cos of angle y. Good. The last one here that I'm going to give you on the bottom of your page is going to be triangle NOP. So let's call this triangle NOP because they're not always ABC that we see. And let's say that we know angle P is equal to 87 degrees. And let's say that we know side length P is equal to 16.9 centimeters up here. And let's say that we know side length N is equal to 13.3 centimeters. Okay, and we're looking for angle O. So let's say we want to find angle O. Okay. Again, let's see what we have. I have a side length here. And I have another angle right here. And then I have another side over here. And the angle that I have is not a contained angle. So this is a side-side angle relationship. And again, I have angle. So angle P, okay, is opposite from side length P. And I have both of those. So if I go ahead and fill that in, there's my little p across from angle P. Okay. So I could use, what am I going to use in this case? I can use my sine law. So I would use sine law. But this is a bit of a tricky one because if I'm looking for angle O here, notice that I don't have the side across from angle O. I don't have side O. I don't have that right now. So if I were to solve this question, first I would have to find angle N first. Okay, I'd have to find my angle up here, angle N, so that I would be able to then I could easily find angle O. Okay, because I have side length N, which is 13.3. So I would find my angle N, and then I would find angle O after that, because it would be 180 degrees, subtract the other 2 angles in the triangle. But I could not use cosine law immediately for this question. So this one was a little bit more tricky because the one I'm being asked for I can't directly find immediately. Okay, let's have a look at another example. This is a word problem, and we have a roof is constructed with 2 rafters of slightly different lengths. So this is not, this roof was going to form a triangle, but it is not an isosceles triangle because the 2 side lengths are different. The width of the roof is 42 feet. The first rafter makes an angle of 48 degrees with the horizontal. okay, or the width of the roof. And the second rafter makes an angle of 44 degrees with the horizontal. Let's sketch a diagram. So if this is my house, the first thing I have here is the width of the roof. So the width is 42. So let's go ahead and draw that. So this is going to be the width is equal to 42 feet, just like that. Okay, there's that information here. And I'm told that the first rafter of my roof makes an angle of 48 degrees. So I can sort of sketch in an angle here of 48 degrees. Okay, so that's going to be rafter 1. Okay, and the second rafter makes an angle of 44 degrees. Okay, so 44 degrees is a little bit of a tighter angle, so a slightly smaller angle there. Okay, 44 degrees. They're pretty close. And they're going to meet somewhere here at the top. So I could get my ruler out, draw some straight lines until, oopsie, sorry. Okay, until they meet. So there's my roof, quick sketch of my roof. And on the right-hand side, there's my rafter, number 2. Okay, makes an angle of 44 degrees with the horizontal. So there's my diagram. What is the length of each rafter? Okay, the first thing that I'm going to be looking for here, the length of each rafter is going to be either this side length here, rafter 1, okay, and then rafter 2. So I'm looking for these two. This is not an isosceles triangle, so they're not equal. Okay, we should maybe write that down. This is not an isosceles triangle. So the rafters are different lengths. How do I know it's not an isosceles triangle? Because my angles of 44 degrees and 48 degrees are not the same. Okay. I can, however, find the top angle right here. Let's go ahead and find this. This is going to be 180 degrees. Subtract the other two angles that I know, 48 degrees and 44 degrees. And so I go ahead and I do that, and that's going to come out to be 88 degrees. So the first thing I should do is go ahead and find that angle. Okay. And now I see that I have an angle of 88 degrees, and I also have the side length that is across from that, opposite from that angle. W is equal to 42 feet. So I have a ratio here that I could use, and I have two other angles, so I could use sine law to go ahead and solve for rafter 1 or rafter 2. Okay, so let's write that down for ourselves. So step 1 here, what is the length of each rafter? I have a side angle pair. Okay, and I have the other two angles. So I'm going to use sine law. Sine law. Okay. So let's go ahead and use sine law for this. We could label our triangle here. It doesn't matter. You could call it ABC, or we can just go ahead and work with what we have right now. Okay. So what I see here is that one ratio, the ratio that I know, is that W, okay, or 42 feet is across from 88 degrees. So I have that ratio. So that's going to be the sine of 88 degrees on the bottom. So 42 across from sine of 88 is equal to, well, let's go ahead and solve for rafter 1 first. Okay, so rafter 1 will go on the top. That's a side length. And I'm going to put on the bottom the sine of the angle that's across from it. So the sine of 44 degrees. Okay, I can cross multiply here. Sorry, wrong way. Cross multiply the sine of 44 by 42 feet so that I get rid of the sine of 44 on the bottom. Okay, and we get this. 42 feet times the sine of 44 degrees divided by the sine of 88 degrees is going to be equal to rafter 1. And so let's go ahead and do that math. And what do we get for that? Let's see. We get 29.2. So 29.2 feet is my units is equal to the length of rafter 1. Okay, so there's my answer there for the length, and so I could go ahead and write that in. So 29.2 feet, and I'll put that into my diagram. Okay, finally then, the other rafter is rafter 2, and again, I could go ahead and use sine law again. That's a really easy one to use, and that would allow me to solve. Okay, at this point as well, I do have a side angle side relationship. So I have a choice now. For the other one, I could use cosine law or I could use sine law, okay, for the second rafter. So let's go ahead and solve for that. Okay, so number 2, for rafter number 2, let me try to do this on the same page. Okay, so let's find rafter 2. Okay, and here I have a choice. So I could use sine or cosine law. Okay, I could use either one. I'm going to go ahead and use sine law because it is a really straightforward one. And I'm going to use the exact same side angle pair that I used when I found rafter 1. So I'm going to use this 42 feet across from 88 degrees as my ratio, and I'm going to set that equal to the ratio of rafter 2 over sine of 48 degrees. So I'm going to do the exact same thing here. I'm going to say that 42 feet over the sine of 88 degrees is equal to rafter 2, this time over the sine of the angle opposite from rafter 2, which is 48 degrees. Okay, so I'm going to have a slightly different answer here. And again, I cross multiply the sine of 48 by 42 to get it out of the denominator. And I get 42 feet times the sine of 48 degrees, all divided by the sine of 88 degrees, is equal to, and if we go ahead and solve for that, it's going to give us 31.2 feet, and that's my answer for rafter 2. Okay, that's my length of rafter 2. And I go back to my diagram and I can put that in there. So that's equal to 31.2 feet. So we use sine law here to solve for all of our unknowns. But we have to start by thinking about what information we're given in our problem. Let's finish this up. It also asks us what the height of the roof is. Okay, so what is the height of the roof? Well, if you want to know the height of the roof, we have to find the distance from the center of my roof here down to the bottom. Okay, so that's going to make a right triangle on the right-hand side and also a right triangle on the left. There's my height right there. That's the height of the roof. So if we are going to solve for this, okay, so the height of the roof is going to create 2 right triangles. So I have 2 right triangles, okay, with a height h. Because when I sketch in my height, it separates that acute triangle into 2. I could choose either the left triangle or the right triangle to go ahead and solve for the height. I'm just going to go ahead and choose to look at the right-hand side here. So let's go ahead and sketch one of those triangles. So let's just look at rafter 2. Okay, so this is going to be rafter 2 over here, and it's equal to 31.2 feet. I'm not really sure what this angle is here. That's not known to me because I know that before in my triangle, that top angle there was equal to 88 degrees, but I'm not exactly this isn't necessarily going to be exactly half of that. So I'm going to use the angle that I know for sure down here, which is 44 degrees. Okay, and I'm looking for h, looking for the height right here. So this, when I have a right triangle, I can use the primary trig ratios. Okay, and the primary trig ratios are SOHCAHTOA, or sine, cosine, and tangent ratios. Okay, on your data booklet, you have them written as sine is equal to opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. We have to look at what we're solving for here. We're solving for h. Okay, 44 degrees. Let me write 44 degrees a little bit more clearly here. 44 degrees is the angle of interest. This is the angle that we're going to label our triangle around. Okay, this is called my angle of interest. In other words, I'm going to label my triangle relative to that angle. So opposite from that angle is h. Okay, that's what I'm solving for, opposite. Rafter 2 is across from the right angle, which makes it the hypotenuse. So I need to use a primary trig ratio that includes my hypotenuse and my opposite side. Okay, so I'm going to use the sine of 44 degrees because it uses the hypotenuse, which I know, and it will give me the opposite, which I need. So here's what I'm going to use. I'm going to say the sine of 44 degrees is equal to the opposite over the hypotenuse. And now let's go ahead and fill in what those are. So sine of 44 degrees is equal to the opposite, which is rafter 2. That's 31.2 feet divided by the, sorry, I apologize. I got to pay more attention here. Opposite, which is h. Okay, that's the height over the hypotenuse, which is rafter 2, 31.2 feet. Okay, let's go ahead and cross multiply the bottom by sine of 44 to get it out of the denominator. So we get the sine of 44 degrees times 31.2 equals the height of the roof, and the sine of 44 times 31.2 is equal to 21.7. Rounded to one decimal place. That is my height of my roof. I chose to use rafter 2, but you could have also used rafter 1 and used the right triangle on the left-hand side, and you would still get the same answer. Okay, you would just have a slightly different, you'd have a different value for your angle and a different value for your rafter. Okay, and there's my answer. Height of the roof is equal to 21.7 feet. C, oh, sorry, there's no question C, just A and B. The very last question we have here is a bit of a complex problem. It involves a diagram that contains an acute triangle as well as a couple of right triangles and some parallel lines. So this is kind of putting everything together. This is given on page 148 of your textbook, and we're going to go ahead and solve for it. So it says, a tree is growing on a hillside, as shown below. So it's growing on a hill. The hillside is inclined at an angle of 15 degrees to an imaginary horizontal line. And the tree casts a shadow uphill. How tall is the tree to the nearest meter? So we're looking for the height of the tree is what we want here. Okay. So looking at the diagram, first of all, I want to recognize that the height of the tree is going to be right here. Okay, this is what I'm looking for. This is the height. Let's call it h. Okay, so that's really what I'm trying to find, is the height of the tree. I've got some parallel lines here. And so what I'm going to do first is solve for as many unknown angles as possible. Okay, let's fill in as many angles as we possibly can and see if that's going to help us solve for h. So that's going to be our first step. We're going to solve for as many unknown angles as possible. Okay, so let's go ahead and do that. What can we solve for? Just looking at this diagram, you may see a couple of things. One thing that I see is that I have these two parallel lines. And what I know about parallel lines is that there are a few different relationships for the angles that exist when a transversal line intersects two parallel lines. So what I see here is that I have this 15 degrees right here, and it forms a Z shape. There's my transversal. There's my other parallel line. So I know that this angle right here is going to be equal to the angle below 15 degrees because those are alternate interior angles. So I could go ahead and fill that in on my diagram. 15 degrees is that little angle right there between the horizontal and the transversal. So let's start there. We have one parallel line in this direction. We have a transversal and another parallel line. And I know that 15 degrees here will equal the other alternate interior angle. So I know that alternate interior angles are equal. So right away that allows me to find 15 degrees up top as well, which is great because now that I know that that's 15 degrees, I could find this whole angle that I have here. Okay, so this angle right here, this total angle, I can find the total for that angle here, okay, of my acute triangle. So this would be equal to 57 degrees plus 15 degrees. If I added those two together, I get the whole angle right there that's formed with the slope of the hill, okay, and this other line that I have, and so that's equal to 57 plus 15 is equal to 72 degrees. Okay, so that's great. I've got that as well. Also, because now that I know that that little angle in my right triangle below is 15 degrees, you might recognize here that I actually have two right triangles in this acute triangle. So I have two right triangles. If you look at the diagram, okay, inside my acute angle, I have a little triangle right here. Okay, that is a right triangle. So there's one on the bottom right there. And then there's also one above it. Okay, so the top of the tree and the horizontal make another right triangle right here. So let's just sketch those out for ourselves. So we have one right triangle right here. Okay, where this is 57 degrees. And then below it, I have another right triangle that looks like this. I'll make that a little bit smaller. Sorry, that's a little bit big. Okay, where this is 15 degrees. So I can quickly find these other two angles. Okay, I know that this angle right here is going to be 180 degrees minus 57 minus 90 degrees for the right angle. Okay, or it'll be 90 minus 57. That's also a good way to think of that. And so that's going to be 33 degrees. So let's go ahead and fill that into our triangle. So that's 33 degrees. And I could go up to my diagram and put that in right here. So this is a 33-degree angle. Okay. And how about this little angle down here in my smaller right triangle right here? Well, I can use that same relationship, 180 degrees, or 90 degrees minus 15 also works, but subtracting the other two angles, so minus 90 minus 15 degrees equals, well, 90 minus 15 is going to be 75. 75 degrees. So there's that little angle right there, and I could go back to my diagram and fill that in right here. Okay, so that's 75 degrees, that little angle right there. So let's see what we have now. We have filled in as many angles as we can. And we have an acute triangle here that has height h. So finally, let's go ahead and find h, the height of our tree. Okay, I'm going to redraw the triangle that I have, the bigger triangle. So there's the height of my tree right there, h. Okay, and I see that it makes a triangle that looks like this. Okay, where I've got 7 meters is along here. Okay, so I'm really just sketching this one triangle that I have. I've got 33 degrees at the top. At the bottom, I have 75 degrees. Okay, and we figured out what this angle was here. 57 degrees plus 15 degrees is 72 degrees. And I could go ahead and just add those three together, make sure that equals 180 degrees, and it does. And so now I'm just looking for the height. I want to solve for the height. So what will I do? How will I go ahead and find that? Well, what I recognize here is that I have, for my height, I have the angle right across from it. Okay, and I also have a side angle pair. I have 33 degrees and the angle across from it. So I can use sine law. Okay, that's what I'm going to use here. So let's go ahead and use sine law for this. So I'm going to set h, okay, on the top here, h over the sine of the angle opposite, so 72 degrees, is equal to the pair that I have. So it's going to be 7 meters over the sine of 33 degrees. And I'll cross multiply the sine of 72, okay, by 7 meters to get sine of 72 out of the denominator. And I get h is equal to 7 meters times the sine of 72 degrees divided by the sine of 33 degrees. Oops. Let's go ahead and give us a little bit of space here. Okay, and so I do that math, and it's going to come out to be 12.2 if I round it to the first decimal place meters, and that's the height of my tree. And there I go. I could have solved for this also by using my two little right triangles that I have. I could have tried to find the height that way as well, if I have a look at it. I could have gone that route, but it would have been a little bit more work. Okay, there was a few different steps that I would have had to do to find the height using my right triangle. So the sine law is the fastest, most direct way. Okay, but the trick here is to try to first get as many angles as you can in your diagram, and then recognize that you have an acute triangle where you have a side angle pair that's known, and we can use sine law. So this is a really great question. It ties everything together. I'd like you now to try some questions on your own. So in your textbook, I've assigned some questions for you. Okay, pages 147. Number 1, number 2A, number 3, and number 5. And trying to decide which law you're going to use and solving some different problems. Good luck. Thanks for joining me, and bye for now.